Now let's look at the long-term steady-state solution of a recurrence relation. So if you look at the linear form, first-order linear recurrence relation, when do you actually have a situation of the steady state? When the p-value is actually approaching or is in between in the range of -1 and 1. Okay, so when you have the p-value is between -1 and 1, that means the term value will approach a constant value when n is becoming very large. Okay, now let's look at the few examples below. From the left here, you have 0.4, and again is fulfilling the range stated. Same goes to the second one, is fulfilling the range stated, and we go to the third one. But then in terms of the diagram, if you look at the first one on the left, it's going downward. The term value decreases and then is approaching a particular value. How do you know that it's approaching a particular value? When the value is actually, the curve is actually approaching a constant or a horizontal line. Okay, and the next scenario is where the value increases and is approaching a constant value. That means the curve itself is going towards horizontal. Now the third scenario is something interesting. You can see that there are two lines from positive and negative here, and then is approaching a constant value. So no matter what the scenario stated here, as long as your p-value is in between -1 and 1, right? That means the term will actually approach a steady-state solution in long run when n is actually becoming very large. Now let's look at the scenario where n is becoming very large. So let's say the n here is actually at 100. Okay, so when it's actually at 100, so the value probably is approaching in this case, right? Is approaching in this case, let's say it's a 5. Okay, and when it's actually becoming 101, okay, 101, what will be the value? Again, it will be about the same value. That means when the term, when it's 100, n equals to 100, is also the same as the term of 101. So what I can say, if it's actually approaching a long-term steady state, that means it's becoming a constant, I can say that the term of n equals to the term of the next term, right? So when it's approaching a steady state solution, you come up with this conclusion. So when it's approaching steady state, this conclusion is what you can draw, and it's actually stated in the following slide here. That means when n is becoming very large, you can assume that the term value is actually ceased to change. That means it stopped to change, it become constant. So do remember to have this. Okay, the term of n plus 1 equals to the term of n. Now let's look at how to solve example 11. They say a sequence is defined by this recurrence relation with the initial value as 4. What value of the terms in the sequence approach in long run here? Now from the question, you know that it's a steady state. Now the first hint is actually being this value, which is your b value. This b value, 0.4, is actually in between -1 and 1, which you have learned earlier. And another hint that you can see is actually they say what value of this term will approach in long run. So you know it's very clearly you are looking at steady state solution. Okay, now let's look at the question here. You have Tn plus 1 equals to 0.4 Tn plus 18. So when it's approaching steady state, what will be the condition? So you have seen in the previous slide, with the steady state, the term of Tn plus 1 will be actually becoming the same as the Tn. That means you can have a constant value. I represent that with x. Okay, then I can put x here, 0.4x. This is x here plus 18. So you have 1 minus 0.4. This whole thing x equals to 18. And you have 0.6x equals to 18 here. X equals to 18 divided by 0.6. You end up with a 30. So, therefore, in the long run, the term in this sequence will approach the value of 30. Now let's look at solving example 12. The sequence having a recurrence relation in this form, and now the terms is actually in the form of u, with your initial term as 10. And they state that the steady state solution here is 37.5, and they want you to find the k value. Now let's solve the question here. U n plus 1 equals to k u n plus 12. Right? And they say your steady state solution is 37.5. That means steady state the term is no more in t but is in u. That means un plus 1 equals to un, and in this case is 37.5. Okay, so you can replace the whole thing here. I just put un first. So I have u and 1 minus k, so equals to 12. Okay, so un being 37.5. So 1 minus k, I end up with 12 here. So that means I have 37.5 minus 37.5k equals to 12. So then I put the 37.5k to the right hand side to make it positive. And then I have 37.5 minus 12 here. So that means I will have a k equals 37.5 minus 12. You have 25.5 and then divided by 37.5. So the answer will be 17 over 25.